Let's move into the next lesson, working with JSTL. As I mentioned when we began the lesson overview, this sub-lesson is focused on the structure of JSTL as well as the installation process. So let's begin. JSTL Design is structured around two broad features. First, there is a set of standard tag libraries, and as we mentioned in the previous lesson, the standard tag libraries simplify the development of common functionality found in many web applications. Things like for loops, for example, or if statements. The second element within JSTL is something that's known as the expression language, also referred to as EL. EL is a bean-oriented expression language designed to simplify access to Java beans. From a tag library perspective, JSTL contains 5 primary tag libraries. In the next sub-lesson, we will explore the core tag library. The core tag library is focused on things like variable manipulation, getting and setting variables, or getting and setting properties associated with a bean. It's also focused on flow control, things like for loops and if loops, or if statements. Things like URL management, encoding of URLs, and then there's some odd and ends things like importing content from other sites. The XML tag library simplifies XML processing within a JSP. So if you have a JSP that imports XML from a web service, instead of you writing the actual Java code to do the XPath navigation or the XML transformations, you can use the XML tag library. The internationalization tag library is focused on localization of output as well as formatting of things like messages, numbers, and dates. The internationalization tag library basically is a wrapper around the java.text package within the core Java platform. The database tag library simplifies interactions with a database. Instead of me as a developer creating JDBC queries by hand, I can use a SQL tag and have the SQL tag perform the query on my behalf. Last but not least is the functions tag library. And the functions tag library provides a simple set of functions dealing with string manipulation and collection examination. The second piece of the JSTL is the expression language. And as I mentioned just moments ago, the expression language is a simplified scripting language. Its primary focus is to simplify the access to Java Bean properties and invoke functions within Java Beans. From a syntax perspective, anybody that is familiar with an ECMA-based scripting language should be able to look at the expression language and understand the syntax as well as the flow. The one thing that may be a little bit different to you as a Java developer is that it is expression-oriented. Expression-oriented means that every time I refer to the expression language or use the expression language, I need to use the expression language to access a property for printing its value out, or I need to access an expression to perform a Boolean test. From a web development perspective, the expression language provides what we normally refer to as a graceful conversion. And all that means in simplistic terms is that the expression language will convert an int to a string or a string to an int automatically for me. It will also treat nulls and empty objects gracefully. Instead of printing null to the screen, it will print a single white space character. This lesson is not primarily focused on teaching you the expression language syntax. However, in order for us to leverage the complete power of the JSTL and the core tag libraries, we need to understand some basic elements of the expression language syntax. The first thing to be aware of is that the expression syntax is typically defined using a $, a squiggly brace, the expression, whatever it is, and then a closed squiggly brace. The expression language, once I have defined an expression in a JSP, is evaluated at runtime. I'm sure you're familiar with the JSP translation process, where the JSP container translates the JSP code into a .java file. The .java file contains a servlet, and then the servlet is compiled and loaded into memory as a class. Within that .java file that is translated, you would find references to some expression evaluation engine allowing the JSP container to execute the expression at runtime. The primary reason that we are pointing this out right now is that if you use the expression language and the expression that you've defined in the expression language is invalid, you will not receive an error by the JSP compiler. Rather, the error will be generated to the end user when they access the page. Within the open and closed squiggly breaks, I can define expressions. You'll notice that my operators for expressions first start off with the dot notation. As Java developers, we should be intimately aware with the dot notation. The second thing is what's referred to as the offset notation. The offset notation is commonly used within arrays. The expression language supports offset notation with strings as well as integers to represent the index. Of course, there's some arithmetic, some equality, and logical operators that I can all include within my expression. With the core syntax behind us, the next thing for us to understand is how the expression language works with our Java beans. Remember, the expression language was created to simplify access with Java beans. In order for a Java bean to be exposed to the expression language, the Java bean must exist in one of the 4 scopes. These scopes should not be new to you. They are the same scopes that are available to us when we use the JSP useBean tag or when we work with a standard JSP. So in order for the expression language to find my Java bean, the Java bean must be placed in that scope, one of those 4 scopes. From a development perspective, I can either have my Java bean placed in one of those 4 scopes manually using the set attribute capability of either the HTTP request or the HTTP session, or I could have my Java bean added to one of those scopes automatically using the JSP useBean tag as well as specifying the scope. From an implicit variable perspective, meaning variables that have already been created and are automatically available to the expression language, you would see a list of variables that look very much like the implicit variables that are available to JSPs. There are a few that are simplifications. For example, in the expression language, I can directly access a cookie, whereas in the JSP language, I have to get an array of cookies and then parse through the array of cookies. The same thing is true when I'm dealing with headers. Instead of me saying request.getHeader, there is an implicit variable that I can work with. Whether I refer to the Java bean using implicit variables or explicit variables, the structure of my syntax looks the same.